idea of integration by substitution is to make a change of variables in order to make the integration easier to perform. That is, we define part of the integrand to be equal to some new variable, then eliminate the original variable from the integration by substituting in the new variable. Once we've done the integrating part, we must then change back to the original variable. Let's have a look at how this works in practice. In the first example, we're asked to integrate 6x over 3x squared plus 1 with respect to x. Now, it's not immediately obvious how to do this using the basic methods we know for integrating powers of x, but it will become easy once we learn how to use integration by substitution. The first time you try to do this, it's not obvious what you should choose as your new variable, and sometimes you might have to try several substitutions before you find the one that works. A common thing to try when the integrand is an algebraic fraction is to let the denominator equal your new variable. So, let's make our new variable, which we'll call u, equal 3x squared plus 1. We need to write the integrand just in terms of u, eliminating any x's, so the next thing to do is to find dx in terms of du. We do this by differentiating u with respect to x, and we get du by dx equals 2 times 3x plus 0, which is 6x. Rearranging this gives du is equal to 6x times dx. If we now look back at the integrand, we see that we have a 6x dx term. So if we now make our substitution, what do we end up with? Well, we replace 3x squared plus 1 with u, and we can replace the 6x dx in the top with du. So, by making a substitution, we've transformed the complicated integral into a much simpler one. We know that this integral is just the standard one, and it's equal to ln mod u plus some constant of integration, c. Now that we've done the integration, we must change u back to the original variable, x. So we get ln mod 3x squared plus 1, because that's what u equals, plus some constant of integration, and then we're finished. Let's look at a second example now, which is a slightly trickier variation of the first. This time we're asked to integrate x over 3x squared plus 1 with respect to x. So let's proceed in the same way and let v, our new variable, again equal 3x squared plus 1. Then dv by dx is 2 times 3x plus 0, which is 6x. So we get dv is equal to 6x dx. However, we don't have 6x dx occurring in the original integrand anymore, but we can rearrange slightly to get 1/6 times dv is equal to x times dx. This can all now be subbed in, so we can write the integral of x over 3x squared plus 1 dx as the integral of 1 over v times 1/6 dv. Now we can take that 1/6 outside the integration because it's a constant, and we're left with 1/6 times the integral of 1 over v with respect to v, which is 1/6 times ln mod v plus a constant of integration. Let's call it d this time. Now that we've integrated, we should convert back to the original variable, x. So we have 1/6 ln mod 3x squared plus 1 plus our constant of integration, d. So the important thing to note here is that the substitution worked because once we had differentiated our new variable, we found that the derivative, or at least some constant multiple of the derivative, appeared in the numerator of the integrand, and this allowed us to eliminate the numerator and the dx and replace them with some multiple of du.